So it turns out that our process of just rewriting logarithmics to exponents or exponents to logarithms will help us actually solve what I call simple equations. Now again, what it means to solve is we got to get the variable, right? X equals, or A equals, or Y equals, whatever the case might be. So we got to do that. And it turns out that if we just make some simple conversions, we're done. So for example, in the first one, the variable x that I'm trying to solve for is up in the exponent, right? But if I reverse this, right, what we get is log, the common log of 23 is equal to x, right? The output becomes the input becomes the output. And lo and behold, I have x all by its lonesome, all right? And in this one, we can actually go to technology and kind of estimate what that solution is. Otherwise, this is called an exact solution, but because log is on my calculator, right? Let me oops, I still got that graph up there. Let me clear that. Let me go, right? So what is the log of 23? Well, it's roughly 1.3617. Let me go out as definite. So it's 1.3617, let's say 28. So I went out about 6 decimals. So the theory, what I'm saying, is if we take 10 and raise it to the 1.361728 power, this is going to be really close to 23. It's not going to be exact because I rounded off the decimal. So we can even check that, right? So if I take 10 and raise it to the 1.361728 power, right, what I get is 23.008. So it's really close to 23 as expected. So exact answer versus an approximate answer, right? And we just got there by doing a simple conversion, right? To get x by itself, I just go from exponential notation to logarithm notation, and I'm done. Same thing here, my x that I'm trying to solve for. Remember, e is a known number. 10 is obviously a known number, so we're looking for e to the x, right? Or we're looking for x. Well, again, if we convert this to its logarithmic form, the base is the natural log, the output's 10, so that becomes the input, and the input was x, that becomes the output. So basically, there is your exact answer. X equals the natural log of 10. But since the natural log is on my calculator, we can actually go look at the natural log of 10. And what I estimate it to be is 2.302585, yada, yada, yada. So again, if we reverse this, if I took e, and it's right there, it's a secondary function. So second e, and I raised it to the 2.302585, right, what I'm going to do is get a number that's really, really close to 10. And again, why it's not exact is because I rounded off, right, the actual answer. So an estimated number versus the exact, but we did solve the equation just by doing a simple conversion. And we can continue to play this game over and over again. So the next one, we start off with 4 to the x power equals 30. So if I just change it to its logarithmic form, we're saying log base 4 of 30 is equal to x, right? The base is log base 4. The output becomes the input becomes the output. So there is your exact answer. And unfortunately, until I show you something a little different, it's going to be really hard to get this estimate because log base 4 is not technically on my calculator until we know what to do and what to look for it. So here, unlike the last two examples where we can get a decimal approximation, right now we got to put this on hold, right? And some of you maybe already know what's coming, but if you don't, just we'll hold on to later and I'll show you. But right now, there's your answer. X is log base 4 of 30, and that's okay. Same thing here, but we have a little wrinkle. Notice that in A, B, and C, the exponential part was all by its lonesome, so all I had to do was convert it and I was done. But in this case, right, there's the exponential part, 0.82 to the x power, but there's this little 20 in the way. So algebraically, let's just divide both sides by 20, and we get 0.82 to the x power equals 1/2. All right, and so if we just use what we're learning right now, right, to convert this, my logarithm will be logarithm of 0.82, right? The input will be 1/2, and its output will be x. And again, I have an exact answer because log of 0.82 is not on my calculator. So again, there's your exact answer, there's your solution. But to get a decimal approximation, we'll basically again have to hold on till later till I show you some more information. So those are exponents. What about logs? Well, same thing, right? Here's the variable I'm trying to solve for. The base is 10, so if I just convert it to its exponential form, we're saying 10 to the 6th power is equal to x, right? Output becomes the input, input becomes the output. So there's our x, and in this case, that's 10 to the 6 is 1, 2, 3, 4, 5, 6. That is 1 million, right? So x is equal to 1 million for that. So again, pretty easy to solve just by making a simple conversion from one form to the other. Here, the base is not known, all right? So this means that we have x to the 2nd power is equal to 16. So there's basically what we need to solve. Taking a square root of both sides, you end up with x is equal to plus or minus 4. But take a look at what x is, right? X represents a base of an exponent, or the base of a logarithm. So the positive one is what we want in this case. It doesn't make sense to have a negative base. We haven't worked with a negative base, so I don't expect that. Even though it came up in the algebra, it's what we call extraneous. So again, a simple conversion using some previous knowledge, we've got our answer. Here, again, we have more going on, but the logarithm, right, is base 10. So I have 10 to the 3rd power equals 2x, right? Output becomes the input, input becomes the output. To get x by itself, I'll divide both sides by 2, and we essentially get 1,000 over 2, which we know to be 500. So that one we can actually go a little bit further because I can evaluate that out. All right, so again, simple conversion, a little bit of algebra. We found our value for x in that situation. Last but not least, we have the natural log of x plus 1 equals 4. So again, making a conversion, my base is e, my output becomes my input becomes my output. So natural log of x plus 1 equals 4 becomes e to the 4 equals x plus 1. And in this case, if we subtract 1 from both sides, we get that x is e to the 4th minus 1. All right, there is an exact answer, but if you want, we can get a decimal approximation because e is actually on my calculator. So I'll go, let me turn it back on, go to second e, we're going to raise it to the 4th power, arrow out of there, subtract 1, and what we get is x is 53.59815, yada, yada, yada. All right, so we can check that if we take the natural log, right, of, so the natural log of 53.59815, add 1 to it, right, we should get something that's really close to 4. All right, so yeah, that's really close to 4. The reason why it's not exactly 4 is because I rounded that x off. So here's your exact answer. We were able to get an approximation because the keys are on my calculator. All right, so we can actually solve some equations, simple ones, just by making a conversion from exponents to logs or from logs to exponents and then using a little bit of math. If the keys are there, we can actually come up with an approximation, or we just keep the exact answer. So here we were able to do both. Here we were able to keep exact. That was easy to do, that was easy to do, that was easy to do. Here, there's your exact, and it's estimate. All right. So more of this coming soon, but that pretty much wraps up 6.4. We've introduced ourselves to the logarithmic function. It serves as the inverse of the exponential function, right? What its graph looks like, how to transform it, how to convert from exponents to logs, just for fun, or to actually solve equations. So much more we need to build on now that we're familiar with the logarithmic function. but we need to move to the next chapter. So see you guys then. As you guys wrap up 6.4, keep talking to each other on Canvas. Give me an opportunity to correct you. Visit me for office hours if you need more help, more explanation, maybe hearing a voice rather than watching a video, all right, will be very beneficial to you. So please come on over if you need help. Otherwise, finish strong. The end is near.